Hello guys, I am Nicholas from the Gravio team, and today we will be exploring a tutorial on how to build a local visual question and answer application without coding. So there are a few prerequisites before you start this tutorial, so please make sure you have them ready. If not, you can pause the video as you go along to get your software services ready before you build the application. So an overview of what we're going to achieve today is we're going to have a folder on the desktop and we'll upload an image to the folder. We will use a no-code platform called Gravio, which will then watch for this folder and pick up the image, the latest image from this folder, which will then trigger a HTTP request to Ollama. And we'll be using Ollama to deploy a large language model, but in this case, it will be a multimodal one because we will be giving the language model a prompt together with an image, and we will get a response, which we would like to use as part of our application. For today's purpose, we will be using Line as a notification or messaging platform. We will also log the results in a TXT file, which we will be showing later in the video. So the underlying technologies of Ollama and LLaVA, these are open sourced, so they are free. Gravio is also an IoT and AI platform where we specialize in connecting AI inputs, IoT inputs, and also creating outputs where we connect to various web services. You can use webhooks and APIs, and we have also customized or pre-built components where you can use out of the box so that you can build your application without coding. So I think we can begin. First of all, we need to install Ollama. And to do that, you can just go to the Ollama website where you can see here, and you can download for your respective OS. And once you've downloaded that, it will run as a service kind of in the background, as you can see here. There's Ollama right there. And then you can deploy models on your local machine. You can run them locally, and you can use them in your application building process. So obviously, one of the key things that you need is processing power, depending on which model you use. But I will not get into the specifics of that today. The next thing that you will need or take note is that having your models run locally will obviously increase the speed, but also the security, because you will be querying the models on a local machine rather than sending data to a cloud service and then back. The model which we will be using today will be called LLaVA. So you can search for that in the library. And this is a multimodal model where you can send an image together with a prompt and query, what is in this picture, for example. So we'll be doing that today. So once you've installed Ollama, which is really straightforward by running the executable file, you can head over to your command prompt and you can just type Ollama. If it's installed, you're able to see all these commands that are available. And if I run Ollama list right now, you'll be able to see all the models that I have downloaded onto my local machine, onto my PC. But I will show you guys how to download LLaVA onto the machine. So on the browser, on the web page, you'll be able to find the command called Ollama run LLaVA. You can copy that and just paste it in the command prompt. It will pull everything that you need, and then it will deploy on your local machine. Once it's done, we'll show you how it looks like. Cool. Now that we have successfully got LLaVA onto our local machine, we can see that there's a success kind of response, and this model is now running locally. You can chat to it, and you should get a response. But obviously, we want to get the most out of it because this is multimodal, so we want to also attach an image together with our prompt. And to do that, we will be using Gravio. So this Ollama part is done. The next part that we need to do is actually build out the entire application, and we will show you how in a minute. Gravio is a software that you can download from our website on gravio.com, where you can install the service locally as well. It's a platform that you can run on the edge or the cloud, so it depends on your scenario. In this case, it's a localhost on my desktop, and you can download Gravio Studio to manage that node. Of course, since it's localhost, I can connect to it locally, and from Gravio Studio, we will start building the application. You can see that I have two sensors here connected already, but that's not relevant to today's video. We can leave that for another day, but these are IoT sensors. And to start, we want to look for a device that is the folder that we have created on the desktop. So to start, we have to find the folder, and in this case, it's just on my desktop. And to see that it says desktop, I have an image upload folder here. I can just copy this file path and add it. It will act somewhat like a camera. So you'll be watching the folder as though it's just watching for a camera for a snapshot. You can just hit add, and you can see the folder image upload has been here. You can check you can change the frequency. You can choose whether you save the image or you want to delete after ingestion for security purposes. That's completely up to you. But what we can do as the next step is you want to hit save, and then we're going to close. Following on, we have to add this into a layer. So a layer is kind of like how you bridge the two softwares together. How you bridge kind of a camera or a sensor to Gravio is the same way of how you're going to bridge this folder data to Gravio. What we call kind of the input side of things. So we just got to look for the camera layer here, and we're going to find the folder that we have just created, which is folder image upload, and we're going to bind it. The folder can be in any kind of file path. You don't have to put it on the desktop or anywhere, somewhere that's convenient for you guys. That will do. We can turn it on, which means that Gravio will be watching for this folder. And then the next step is kind of building the last bit on the right side. So what we've done so far is we have managed to build everything on the left here, where Gravio is watching for a folder, and we're going to get this as the input, and we're going to create an output where it creates a HTTP request that's local to Ollama, and then we're going to get a LLaVA response, which we're going to use down the line in the application to post it out to line and also return to a text file. So let's continue. To do the next step, we have a page called actions. You can think of each action as a micro application. I can see I have a few of them built already here. So we're not going to focus on any of them today. We're going to create a completely new one called LLaVA API. So we can double click on the action, and we can go into the action builder. So in the action editor here, you can see this is actually where you build an application. It's very visual. It will run in steps, and you can use any of the pre-built components to build an entire enterprise application or something as small as a proof of concept. So we can go as low as executing a script if you need to, but today we'll be using HTTP requests. But as a first step, we have to read the file of whatever that's coming into Gravio, of the image basically. And to do a file read, we just got to set the file name to tv.data. So these are Gravio specific naming conventions. You can find that on our Gravio documentation, but it will be consistent throughout the application building process, and you do not have to learn everything over and over again. There will be a slight learning curve, but there's not too many kind of variables where you have to learn. So once you have read the file, this will read the file in a, I think it's in a raw format, and we got to change that to base64, which we will do it down the line, because in the LLaVA API, you can see here, this is kind of like a base64 format. All right. So after you read the file, we can create the API request. In this case, we want it to set it to post, and we're going to set the endpoint URL to something that we have seen before, which is over here. The endpoint URL should be this one. We're going to copy that, hit on over, and then the content type, it will be application/JSON. And we can leave the rest blank because we don't have anything else set up as we know. All right. Then we're gonna go on to map the payload. So we always have to set the payload to something to bring the data down the line. So what this means is you have to set the payload from the previous step to the next step. I think as we go along, it will become much more clear to you guys. So we can just call whatever's in the body. This is kind of in the payload, that's the body. And then we can set the model to lava, and we can set the prompt to say maybe how many people are there in this image, reply with only the number. So we can try that for now. And you can see here, the previous payload from the file read will be converted to base64 using the base64 function. We're going to set the stream to false just because we don't want a lot of responses in each payload. We just want one kind of response. So that's why we set it to false. And then as a next step, we will start building out the line notification. So here, the most important part is the message. We want to set the message to be the previous payload, which is the AI response from LLaVA. And to do that, we have to use a JSON path. The reason is because the response from the AI will be sent in, there are many different keys and many different values, and we only want the response as the value. So we're gonna set that, and we're gonna take it from the payload that was from the previous component, which is the HTTP request. So now that we have that set up, we can then set a token, which I've saved from before, for example, AI response. And for the last step, we want to write a text file. So we want to write the results in a text file. We can do a file write, and then we can do AI results.txt, for example. We can append it, and then we want to set the payload of the response to the text file. So we're going to do the date and the time now, or the time of the response, plus a text saying OpenAI response. No, that's wrong actually. It should be LLaVA response. And then we're going to set the payload, which is the response, and we're going to do an append as well. So now we have all of that set up, we can then go and test out the application. We do have a compiler here, but obviously I don't have any images in the folder, so we're going to set it up before we can test it out. Actually, before I go on, we want to set the message. We're going to set the payload to be the message so that we don't get any confusion when we go on to the next step, and the payload will be just the message. So the last step, right? Just to recap, we have already built kind of the front part, which is the ingestion of the image from Gravio. And then we created a HTTP request from the component, and then we also created the line and text file component from the LLaVA response. So now we want to see everything in action. And to achieve this, we have a page for triggers. And a trigger is it's basically self-explanatory. It is a trigger. So we can say whenever there's an image upload to the folder, and we're going to say the image upload folder, you can specify a file name if you're watching for a certain file. But in this case, I'm going to use any. And I'm going to map this trigger to the action, which is LLaVA API. So what this means is that whenever there's an image dumped into a folder, you will pick it up from the input side as part of the condition, and then we map it to an action to run when this folder has something that's picked up. It's basically as simple as that. So when we hit save, we can turn it on, and now we can test it out. So what we're gonna do is we're gonna go to the web and look for people sitting in a cafe, for example. And maybe this image is kind of blurry though. Maybe this one. We can do save image as, and then we can look for the image upload, and then make sure it's in JPEG or PNG, and then we can hit save. And we should be able to find the result from here. So you notice that it's still providing in text. We can then go ahead and change this by going to the prompt and say reply with only the number in digits / numerals. Do not use any text. We can go back and that will automatically save. And we can use the same picture again. We can save it. And once it's uploaded, we can see that the AI response has now given just a number. And it's a very quick way to even build something, a proof of concept that uses everything that's local, and you don't have to train any of these TensorFlow models or any computer vision models by yourself. You can utilize an already pre-trained large language model to achieve certain results that you want to, that can be deployed really easily and really, really quickly, especially without coding. So we can check the TXT file as well. It's part of our workflow from before. So we want to look for the folder. This is going to be stored in the HubKit folder, which is the Gravio service. You can look for the action manager, and here you can see the AI results. Let me just bring it over to this screen here. So we have the response. It started with 2 people in this image, and then it kind of matches up right here. I think that is it. That is the end of the application building, right? How long did we take? Probably like 15 minutes, 20 minutes. I think this is a very powerful way to build and test or even deploy proof of concepts, even at a small scale. And once the results are good, you can start scaling up with Gravio as well. And of course, Ollama is a really handy tool, so please check it out. We have also a free version of Gravio where you can check it out. And thank you so much for watching to the end of this video, everyone who has been watching. If you want to find out more, please leave something in the comments or a comment below, and we will definitely reach out to you, not only in the AI space, but also in the IoT space. All right, catch you guys in the next one. Peace.